two slits are separated by a distance. Okay, so our D is 0.251 times 10 to the minus third meters. The wavelength is 647. Let's see, interference pattern. The separated by a distance. The distance on the screen is 0.0152 meters. So I guess we want, okay, so they want us to tell how far away the screen is, right? Okay. Okay, we can do this. So let's see. The formula in the data packet is S is lambda D over D. And we want to solve it for big D, the distance to the screen, right? Okay, that's what they're asking for, right? So D is going to be S D over lambda. Is that right? Yeah. Did I clear the fraction correctly? Okay, so it's going to be 0.0152 times 0.251 times 10 to the minus third. And then we're going to divide by wavelength, 647. All right, let's solve for that, baby. Okay, so 0.0152 times 0.251 e minus 3 divided by a small number, 647 e minus 9. And I get 5.89675. We have to round it to that. So we would say that big D is equal to 5.90 meters. All right. Woohoo! Okay, so let's do B. We want to find the angle between the central maximum and the fourth order maximum. Not going to be a big angle. Okay. And there's a couple ways to do this. Let's do it the simple way, though, I feel like. Okay. So this is Young's double slit, right? So n lambda is d sine theta. And we want to go from the central to the fourth, so our n is going to be 4. And our wavelength is 647. And then that's going to equal our distance between the slits, right? So 0.251 times the sine of that angle, right? So the angle is going to be the inverse sine. We got to do a little math here, right? Okay, so inverse sine of 4 times 647 e minus 9 divided by 0.251. And I'm getting that angle is a whopping, is equal to 0.59077. It's about 0.591 degrees. And that's an impossibly small angle, right? Okay, but remember these are small, right? Okay, now here's the thing, right? The other way to do it is that the central is here, and then here's the screen, right? We know that this distance here is how far? 5.8967 meters. We just figured that out. We know that this distance is 4 times 0.0152, right? So we ought to be able to find the inverse tan of that. Let's do it. Second tan of 4 times 0.0152 divided by that distance to the screen. I'm not using the rounded version. Holy cow, I get the same number. It diverges at this place, right? So our this analysis and that analysis are darn near the same. Okay. This one's correct. This one is, I guess, approximate, right? Because these distances wouldn't be exactly that, right? They're close. They're very close.